So in the formation of an ionic compound made from magnesium and oxygen, of course, magnesium has the atomic number of 12, oxygen has the atomic number of 8. And you can see, according to shell distribution for magnesium, you have 2, 8, 2. Of course, the M shell carrying the 2 electrons is the valence shell. And here the shell distribution is what? 2 and 6 for K and L. And of course, the 6 electrons is found in the valence shell, which is the L shell. So just to depict only the valence shell, we use the Lewis symbol. So you see 1 dot here, 1 dot here, denoting the 2 electrons in the outermost shell of magnesium, and you have 2 lone pairs of electron and 2 unshared electrons. So we have 2, 4, 5, and 6 electrons around oxygen, denoting this. Recall what happens in ionic bonding is the transfer of what? The valence electron of metal to the non-metal. So when these 2 is transferred, of course, this value of 6 will increase by 8. That's why, of course, it ionizes because it receives that electron. That's why you have 2 8s in the K and L shell. And of course, because we've removed these 2 from this shell, of course, the magnesium 2 plus ion now has 2 shells. You have 2 and 8, okay? Again, so this is important. If you look at it critically, you understand that magnesium 2 plus ion and oxide 2 minus ion are said to be isoelectronic. They are said to be what? Isoelectronic, in that they have equal number of what? Electrons, or you call them isoelectronic species, okay? Because this is 2 and 8 and this is 2 and 8. This is exactly what we have in muon, okay? So equally, you can see that 3 of them are said to be isoelectronic species, in that all 3 of them, okay, this is a neutral compound, sorry, a neutral atom, 2 and 8 muon, but these are ions. Of course, they all have 2 and 8 electrons, which is total number of 10 electrons. In that case, they are said to be isoelectronic. So back to magnesium oxide, you discover that the 2 plus 2 and minus 2 cancels out. So ultimately, we're going to have MgO, magnesium oxide, which is the resulting compound, which is what? A neutral compound that has a net charge of 0. Neutral molecules or compounds has a net charge of 0. This is because the charges will do what? Cancel out. Plus 2 minus 2 is 0. So that is what you have. So the first point here is that the resulting compound is a neutral compound, a neutral molecule, okay? Then second point here is that, of course, this Mg2 plus and these O2 minus ions are held together by strong attractive forces, okay? However, it is important to know that the magnitude of the charges are the number in front of the charges. Here you can see the both magnitude is 2 and 2, just like we have in sodium chloride 1 and 1, okay? The magnitude of charges in the both ion is, of course, 2 and 2. And you discover that 2 and 2 is more than 1 and 1. So we expected that the higher the magnitude of the charges, the stronger the forces of attraction or the electrostatic attraction. So ultimately, we're expecting to have that the electrostatic bond formed or attraction formed in magnesium oxide should be greater than that formed in sodium chloride. Okay, so the electrostatic attraction in magnesium oxide should be more and is more than that found in sodium chloride, because the magnitude of charges in sodium chloride is is 1 and 1. Okay, I told you magnitude is the number of the charges. Okay, so the higher the number of the charges, the higher the electrostatic attractive forces, okay, or the higher the ionic bond. So we're expecting to have stronger ionic bond formed in magnesium oxide than found in sodium chloride. Did it make sense? If it made sense, please kindly share this video. Nice.